Welcome to The Explainer. I am so excited to have you here today because we're doing something really fun. We are officially cracking open the AI toolbox. We hear terms like deep learning, neural networks, and algorithms thrown around literally constantly in the news right now. But today we're keeping it simple. We're going to strip away all that intimidating jargon and look at these advanced machine learning concepts for what they really are. Highly specialized, incredibly fascinating tools that absolutely anyone can understand. Okay, let's dive right into this. Here's our roadmap for today's explainer. 1. The AI brain. 2. MLPs, building the foundation. 3. CNNs, seeing spatial data. 4. RNNs, remembering sequential data. 5. The machine learning landscape. And finally, number 6, decentralized AI and you. I promise you a simple, step-by-step breakdown of these specialized tools. Section 1. The AI brain. Separating pattern recognition from magic. So, first things first, AI isn't magic, right? It is a highly structured approach. To really grasp the digital economy, we need to distinguish between two foundational terms using the Hive AI v3 framework. Machine learning is basically the broad umbrella. It covers all the algorithms that let systems learn from data without being explicitly programmed by a human. Underneath that umbrella, we have neural networks. These are specific computational models directly inspired by the human brain, built to spot really complex patterns and make decisions. Think of it like this. Machine learning is the entire workshop, and neural networks, well, they're the most advanced high-tech workbench inside that shop. Section 2. MLPs, building the foundation, the bedrock of deep learning. To really get how MLPs work, we've got to bust a major piece of jargon right out of the gate, the activation function. Simply put, an activation function is just a mathematical twist. You might hear people toss around terms like ReLU or sigmoid, which honestly are just different mathematical shapes. But what they do is introduce nonlinearity into the network. Why does that matter? Because without this little twist, even a massive, super deep neural network would just act like a very basic flat linear model. The activation function is literally the secret sauce that lets the network untangle and actually solve messy, complex real-world problems. Let's turn this wildly complex mathematical process into an easy-to-follow recipe. Just watch the journey of the data here. Step 1. The input layer receives the raw data. Step 2. The hidden layers start processing those inputs. Step 3. That crucial activation function we just talked about applies its nonlinear twist. And finally, Step 4. The output layer delivers the final decision. It's like an assembly line. Every single neuron does its job and passes its work right to the next layer in this highly organized flow. And because of this beautifully structured assembly line, MLPs can learn to connect the dots in almost any complex situation. Now, in academic circles, you'll hear people say MLPs can approximate any continuous function. But in plain English, it just means they're incredibly versatile multi-tools. They are absolutely perfect for everything from categorizing your customer data to predicting future stock market trends. Section 3. CNNs, seeing spatial data, the eyes of the AI toolbox. Okay, moving on to CNNs. These are built specifically to handle what we call spatial data. Let's drop the jargon again. Spatial data is really just grid-like information where the physical layout actually matters. Think of a digital photograph. An image is just a grid of pixels, right? And the physical arrangement of those pixels is what actually creates an edge or a texture or a human face. That is exactly the kind of input these visual eyes are built to analyze. So how do CNNs achieve that vision? They use convolutional layers equipped with learnable filters, sometimes you'll hear them called kernels, acting kind of like mini magnifying glasses, to detect very basic edges and shapes. Then, pooling layers step in to shrink that data down. They filter out the noise and make the network robust, so it doesn't get totally confused if a shape shifts slightly to the left or right. This creates a really cool process called hierarchical feature extraction. Basically, the AI sees a straight line, then it sees a curve, then maybe an ear, and finally, bam, it recognizes a cat. It's exactly why CNNs are unparalleled for image recognition and even complex medical imaging analysis. Let's compare our first two tools side by side to really lock this in. On the left, we've got CNNs. They're explicitly designed for grid-like images, and they use spatial awareness to zoom in on local patterns. Now, on the right are MLPs. They're general purpose, connecting every single neuron to every other neuron in the next layer, but they completely lack that spatial awareness. I mean, you wouldn't use a hammer to turn a screw, right? And you definitely wouldn't use an MLP to analyze a photograph. So we have a tool for basic connections and a tool for vision. But that brings us to a really critical question. How does an AI actually remember what it just read in a paragraph, or what you said 5 seconds ago in a voice note? Section 4, RNNs, Remembering Sequential Data, the memory of the AI toolbox. To answer that question, we use RNNs. They're designed to digest sequential data. Unlike a static image, sequential data is information where the order and the passage of time absolutely matter. Think about the words in a sentence, a clip of human speech, or a time series of a stock's price over a week. If you scramble the words in a sentence, the entire meaning is destroyed, right? RNNs fix this by having an internal memory that lets them retain information from previous steps. This allows them to actually understand context and dependencies as time flows forward. Now, to be fair, early on, basic RNNs suffered from a major flaw known as a vanishing or exploding gradient. Basically, they had terrible long-term memory. But AI researchers fixed this with amazing advancements like LSTMs, which stands for Long Short-Term Memory, and GRUs, or Gated Recurrent Units. You can think of these like highly upgraded memory chips installed straight into the network. They solve the forgetfulness problem entirely. In fact, these are the exact tools powering the incredibly advanced natural language processing and speech recognition apps that you and I use every single day. Section 5, the machine learning landscape, organizing the paradigms. So the crucial takeaway here is that beyond just neural networks, machine learning algorithms broadly fall into 3 main buckets based on how they actually learn. Let's break them down. First, supervised learning. This uses labeled data to predict outcomes. It's literally like a teacher giving the AI an answer key to study from. Second, unsupervised learning. This works with unlabeled data to discover hidden patterns and intrinsic structures entirely on its own. It's flying solo. And third, reinforcement learning, where an agent learns to make decisions by taking actions in an environment to maximize a reward. If you've ever seen advanced robotics or complex game-playing AIs, this is the engine behind them. Section 6. Decentralized AI and you. The Hive HIV-3 vision. Okay, so what happens when we take this incredible AI toolbox we've just unpacked today and actually combine it with blockchain technology? Well, we entered the decentralized era. According to Hive, this convergence means advanced models don't just belong to massive faceless corporations anymore. Nope, they can be collaboratively trained and verified by the network itself. It creates a system of true data sovereignty and actual community ownership, perfectly fostering a philosophy where you can learn, share, and earn. You actually get rewarded for participating in the AI ecosystem. How cool is that? And guys, this isn't just theory or some sci-fi future. From fintech to digital marketing and modern entrepreneurship, these neural networks are fundamentally reshaping the very foundation of our digital economy right now, today. Taking the time to master these basics, demystifying this jargon, gives you a massive, tangible edge as this technology continues to explode. Which leads me to this final, pretty provocative thought for us to end on. If communities can now collaboratively train and truly own decentralized AI, what new world will you build with your AI toolbox? I really hope this explainer sparked your curiosity and showed you that these complex tools are absolutely within your grasp. Thanks so much for learning with me today, and keep exploring.